poles. Then the condition that I will be calling is between the value of zeta to be between 0 to 1. So at that time, what are the two poles that I am going to consider is one pole is this and another pole value is this. So the first pole value is minus zeta omega n plus j into omega n root of 1 minus zeta square, and the second pole value is same thing, instead of plus I will be considering that as minus. Now under this condition, if I draw the graph, where are the two values that I will be getting? So minus zeta omega n plus j omega d minus zeta omega n minus j omega d are the two values that I will be getting. And if this is my function with respect to the delta, if I form a triangle here, then this will be my omega n value and this will be my omega d value, which is omega n into root of zeta square. And what will be the value of theta? We already know the value of theta is tan inverse of root of 1 minus zeta square by theta. Then this function is what? This function is zeta into omega n function. For this particular type of system, what if I feed that in the system? What is the type of response that I will be getting? This is the type of response that I will be getting from the equation number 6. Which was your equation number 6? Our equation number 6 was this. So in this equation, if I substitute the value of zeta to be between this to this, then what is the type of response that I will be getting? The type of response that I will be getting is this. And what is such type of response called as? Such type of response is called as what? Underdamped response. Next, when I substitute the value of zeta to be equivalent to 0. Now when I substitute the value of zeta to be equivalent to 0, then what are the two types of roots that I will be getting? The two types of roots that I will be getting when I consider the value of zeta to be equivalent to 0 is the imaginary poles. So if I say that they are imaginary poles, then I can put the value of s to be equivalent to what? Plus j omega n and minus j omega n. And what is such type of response called as? When zeta is equivalent to 0, the type of response is called as an underdamped case. Now again, recall the equation number 6. In this equation number 6, wherever you have zeta, just substitute the value of zeta to be equivalent to 0. If the value of zeta to be equal to 0 in equation number 6, then this is the equation that I am getting. This sine of phi plus pi by 2 can also be written as cos of omega n into t. So omega n will oscillate the system and the damped frequency is always less than that of an undamped frequency because of the value of this zeta. Then how is the response for the underdamped case? The response for the underdamped case is like this. That means the oscillations is called as the sustained type of oscillations. Next, coming to the third condition. What is the third condition? The third condition is critically damped condition when the value of zeta is said to be equivalent to 1. Now, when the value of zeta is equivalent to 1, what is the substitution that we will be making or assumptions we will be making? The system has two real and equal poles. So, if I am saying that the system is having two real and equal poles, then this is the point. At zeta is equivalent to 1. So, I am making the substitution here, and what is this type of condition called as? This type of condition is called as the critically damped condition. Now for zeta is equivalent to 1. Again, let us recall our equation. What was our original equation? Our original equation was 1 by s into omega n square by s square plus 2 zeta omega ns plus omega n square. Now what is this denominator? This denominator, as we previously did, it is nothing but a plus b the whole square expansion. Therefore, omega n square divided by s into this, I will be writing it in the form of s plus omega n the whole square. So if I just expand this, a square is nothing but s square plus b square is nothing but omega n square plus 2ab is nothing but 2 zeta omega n into s. Now what I do? I convert that into the partial fraction. When I convert this into partial fraction, that is omega n square by s plus omega n square, this is the value that I will be getting. 1 by s minus 1 divided by s plus omega n minus omega n by s into s plus omega n. Now what I do? I take the Laplace transform for this particular equation. So your S domain will be now converted into what type of domain? From the S domain it will be again converted back into the time domain. So what will be C of S now? C of S will be converted back into C of t. Then inverse Laplace transform of 1 by s is equivalent to 1. Inverse Laplace transform of 1 by s plus a is e to the power of minus a into t minus omega n 1 by s plus a is t omega n into e to the power of minus a. But a is here now what? Omega n into t. Therefore, 1 minus, in both these equations I can take out e to the power of minus omega nt outside. That is common in both the term. Therefore, this is a common term. So here it will be equivalent to 1 minus omega n into plus omega n into t, because minus is here. I can just write this as plus. This new equation I will be calling it as equation number 8. So from the equation 6, it is clear that zeta omega n is the actual damping, and for zeta is equivalent to 1, omega n is called as the actual damping. What is this known as? This is said to be what? Critically damping. Now, the ratio of actual damping to the critical damping is known as what? The damping ratio. This damping ratio response, if I draw, then this is the response that I will be getting. Now there is one more case which is called as the overdamped case. And what is this overdamped case? This overdamped case, we need to consider the value of zeta to be greater than 1. So if this value of zeta is greater than 1, that means somewhere here two distinct real and two distinct poles I have to place. So here one I am placing and here one I am placing. So one I will consider to be positive omega n and another one I will be considering it as a negative omega n. And what is the type of response I have to get? This is the type of response that I will be getting for the case which is said to be the overdamped condition. Now let us recall this equation back. So here what I have here is one was positive and one was negative. Therefore, omega n square by s plus zeta omega the whole square minus omega square into zeta square minus 1. Now again make the substitution omega d square as omega n square into zeta square minus 1. So whatever this part of the equation is there, it will be replaced by what? Omega d square. Now whatever this equation number 10 is there, this equation number 10 as a whole can be written as omega n square by s plus s into s plus zeta omega n plus omega d into s plus zeta omega n minus omega. Now we will be taking the partial fraction of this equation number 11. For this equation number 11, I need to take the partial fraction. This one term separately, this one term separately, this one term separately, and for omega n squared term separately. So the first part I will be writing it as it is, and for the second part, wherever omega d is there, replace that by omega n into root of omega n square. So I am getting this and I am getting this part. Now wherever omega d is there, make that particular substitution. So omega square minus 1, and here also it is omega square minus 1. Now if I take the inverse Laplace transform for 1 by s, what is the inverse Laplace transform? For 1 by s, the inverse Laplace transform is nothing but equivalent to 1. And for the next term, for this term, 1 divided by 2 into zeta square minus 1, for this entire term, what is the Laplace transform? Denominator you keep it as it is, numerator will be to the power of minus zeta plus root of zeta square minus 1 into omega n into t. For here, instead of the same thing again, here instead of minus plus, you will be having a minus sign here. So call this as your equation number 4. From this equation number 14, we get two time constants. What are the two time constants that I am getting? One is here and another one is here. That is 1 by zeta plus zeta square minus 1 into omega n, and the another one is here 1 divided by zeta minus root of zeta square minus 1 into omega n. These are the two time constants that I will be getting. So equation 14 is clear that when the value of zeta is greater than 1, then there are two exponential terms. First term has the time constant t1 and the second term has a time constant t2. And always whatever the value of t1 is there should be lesser than t2. Or in other words, we can say that the first exponential term decays much faster than the second exponential term. So for the time response, we just neglect that and we write what is our C of t equal to. And in this C of t, what is the value of t2? So this is our value of t2. Now, how we had time domain specifications with respect to the first order system, similarly we have time domain specification for the second order systems also. So the first thing that we wrote here is all the conditions that we considered. Now you can see here 0.5, that is nothing but half. For this 0.5, we can see that this is called as the delay time. That is the time taken to reach the 50% of the maximum value is called as the delay time. The time here is nothing but the rise time here. This is called as the TR time. And this TR is nothing but called as the rise time. And what is this TP? This TP is nothing but called as the peak time. This is called as the first maximum overshoot and this is called as the first maximum undershoot. This is called as the second maximum overshoot and this point is called as the second maximum overshoot. Now we need to find out what is TD equal to, what is TR equal to and what is TP equal to. In the similar manner, we also have one more term which is called as the peak overshoot, that is denoted by MP. This MP can be of whenever the time that we have is this is nothing but the settling time is there. This particular settling time can have a percentage of plus or minus 2% or plus or minus 5%. So when 2% is there, the settling time formula will be different, and when 5% is there, again the settling time formula will be different. Now, what is the delay time definition? The delay time, as you saw in the previous one, was obtained at 50% from 0. That means, what is the definition telling you? The delay time is the time required for the response to reach 50% of the final value in the first time. Right? So, we have the delay time TD. Then, what is the rise time TR? What is the value of this delay time? The equation for this delay time is pi by omega n into root of 1 minus omega. Now, what is this rise time definition equal to? The time that is required for the response to rise from 10% to 90% of its final value for overdamped systems and 0 to 100% for underdamped system is nothing but called as the rise time. So, what is the formula? We already have this formula. C of t is equal to what? 1 minus e to the power of minus zeta omega nt by root of 1 minus zeta square into sine of 5 plus 5. So here, what is phi value? We know that it is equal to tan inverse of root of 1 minus zeta square divided by zeta. And now what we will be doing? We say we are telling that the response reaches 100% of the desired value. Therefore, what will be the value of C of t? So 100% means what? That means like this completely. And what is this condition? This is your C of infinity. And what is the C of infinity? That C of infinity is always equivalent to 1. Therefore, I am making the substitution that C of t is equivalent to 1. So, 1 is equal to 1 minus of this one. So, this one and this one gets cancelled and I am equating this value to be equivalent to 0. Right? Now, after equating this value to 0, I am saying that e to the power of minus zeta omega n into t is not equivalent to 0. If this is not equivalent to 0, whatever the second part is there, that must be equivalent to 0. Therefore, the second part I am equating it to 0. Or this also I can write it as what? If I want, I can take this the other side. So, if I take that the other side, then it is sine of n phi. But what will be the value here? N can vary from 1, 2 until etc. And here let us consider the value of n to be equivalent to 1. When the value of n to be equivalent to 1, there is a repetition here. This sign is not there because I have already taken it this side. So you will be having that as pi. Sine, both the sides I can get cancelled and I can put t to be equivalent to tr. Now since sine and sine got cancelled here, what is the value of rise time? Pi minus phi divided by omega n into root of 1 minus zeta square. So this is the value of the rise time, which is nothing but equivalent to tr. Now the next one, that is nothing but the peak time Tp. How to derive the equation for the peak time? What is it saying? The definition says that the peak time is the time required for the response to reach the first peak of the time response or the first peak of the overshoot. Right? That means what? This one. How do I reach at this particular point? Okay. So again rewrite the same formula here. But what I have to take the condition is wherever C of t is there, differentiate that with respect to t and equate it to 0. So d C of t divided by dt, entire term I am replacing as it is, then I am differentiating this term. So when I differentiate this is the equation that I will be getting. After differentiation, I know that this cannot be equivalent to 0. Because if I make this as 0, the entire term will become 0. So this cannot be 0. Whatever the remaining part is there, that remaining part can be written as this. Cos will be equivalent to sine. And what is root of 1 minus zeta square? Again, consider the same thing. Theta here or 5 here, whatever it is. Root of 1 minus zeta square here, 1 here and zeta to be here. So you can find out what is sine phi and also I can find out what is the value of my cos phi. Then I can equate both and divide one by the other. Therefore, this entire function I am calling it as phi and this entire function again I am calling it as phi. One by the other I am just taking. So it became what? Sin by cos is equivalent to tan function. So tan of this one. Here next what we will be saying, whatever the time is there, that particular time is equivalent to what? It is called as the peak time, which is nothing but equivalent to Tp. So put T will be equivalent to Tp. So omega n into root of 1 minus zeta square into Tp is equal to n pi. Now what is the value of n? First, second, third, like this. First, second, like this it can take any value. Now I am finding out for n is equivalent to 1 for the overshoot here. Then I have to find out for the undershoot at this particular point. So pi, that is now what I have to do here, I will be substituting the value of n to be equivalent to 1. Pi by omega n into root of 1 minus zeta square, and the first minimum will be equivalent to what? That is 2 now. N will be equivalent to what value now? The value n is equivalent to 1 year, n is equivalent to 2 year, n is equivalent to 3 year and n is equivalent to 4 year. So T minimum will be 2 into pi by omega n into root of 1 minus zeta square. So the first overshoot and the first undershoot we have obtained. So N1, N3 like that odd numbers will be the overshoot. All the even numbers will be nothing but our undershoot values. Next one is the maximum overshoot MP. For this maximum overshoot occurs at the peak time T is equivalent to Tp. So I know what is the value of Tp, which is pi divided by omega n into root of 1 minus omega n square. What I will do, I will substitute here Tp if I consider at this particular point, I will substitute that value. So when I substitute, this and this gets cancelled. After cancelling, this is the term that I will be getting. So in this particular term, I will be again putting what is sin phi equal to. What is sin phi equal to? Root of 1 minus zeta square. And what is sine of pi plus phi equal to? Sine of pi plus phi is equivalent to minus sin phi. So I am just substituting that. Sine of pi plus phi is minus. So here what happened? This negative sign now become positive and this became the sin phi function. And what is root of 1 minus zeta square? That also is equivalent to sin phi function. So this 1 minus zeta square and this 1 minus zeta square gets cancelled. The remaining term whatever is there, we will write it as it is. So what is the maximum peak overshoot here? The maximum peak overshoot formula is this, or I can also call it as what? C of t minus 1, because from the first one to the maximum peak overshoot, whatever the value I will be getting according to the definition. What was the definition? So at t is equivalent to Tp. This is the definition. So at that point, C of t minus 1. So what is C of t I have got here? That minus 1. Here plus 1 and plus 1 minus 1 I am going to cancel, and this is the maximum overshoot here. If you want this maximum overshoot in terms of percentage, then this you have to multiply that with 100. Next is the settling time Ts. What is the definition of the settling time Ts? The settling time Ts is defined as the time required for the transient response to reach and stay within the prescribed percentage of error. It will reach there. After reaching, it has to stay back there. So that is called as the settling time Ts. So this settling time Ts can be with respect to certain percentage of tolerance band. That percentage of tolerance band can be of two types. One is plus or minus 2% and the another one is plus or minus 5%. For both of these, the formula will be different. So if I say plus or minus 2%, that means 98%. Out of 100, either it can be 102% or it can be either 98%. So suppose if it is 98%, that is plus or minus 2%, then it is 4 times of t. And what is t? T is equal to 1 by zeta into omega n. 4 times of the time constant t. But what is t equal to? T is equal to 1 by zeta into omega n. Therefore 4 by zeta omega n. Suppose it is plus or minus 5%, then the equation will be 3 by zeta into omega n. If nothing is specified in the problem, we go for plus or minus 2% tolerance band. If they mention that it is plus or minus 5% tolerance band, then to calculate the value of Ts, I have to use this formula, that is 3 by zeta into omega n. Similarly, the last definition, that is the steady state error, which is defined as the difference between the output and the desired output as the time t tends to infinity. So, R of t minus C of t, we will be getting the steady state error. Now we'll just take one example. Now in this example, the open loop transfer function of the servo system is given, which has a unity feedback. Since it has a unity feedback, only g of s is mentioned here, and the value of g of s is 10 divided by s plus 2 into s plus 5. They have asked us to determine the damping ratio, underdamped natural frequency of oscillation. That is nothing but omega n, and the value of zeta we need to find out. Then what is the percentage overshoot of the response to the unit step input? Percentage overshoot we need to find out. Percentage of overshoot we need to find out. Now we know that for any given open loop function, if we want to find out the characteristic equation, then we are supposed to use the formula 1 plus g of s into h of s to be equivalent to 0. Now what they have told here, unity feedback, open loop with the unity feedback. Since they have told us unity feedback, what is the value of h of s equal to? The value of h of s is equivalent to 1. So 1 plus g of s into h of s will be equivalent to 0. So here g of s into h of s, whatever is there, I am just substituting that as what? 10 divided by s plus 2 into s plus 5. Now when I rearrange this and I do this, I will be getting it in the standard form as s square plus 7s plus 20 to be equivalent to 0. Now what I do, whatever the second order function I got, quadratic function I got, I compare with the standard characteristic equation. What is the standard characteristic equation? S square plus 2 zeta omega ns plus omega n square to be equivalent to 0 is the standard function there. So from this equation, what is this? This is equivalent to this. So what is omega n square equal to? Omega n square is equivalent to 20. Now let us compare this 7 with this 2 zeta omega n. So 2 zeta omega n is equal to 7. Now from this I want omega n. So omega n will be equal to how much? Root of 20. How much is root of 20? 4.47. And what is the units? Always omega natural frequency will be measured in radians per second. Now since I got the value of omega n, I can substitute the value of omega n in this equation, that is 2 zeta omega n is equal to 7. Now from this I can find out what is the value of zeta. So it is 0.7826. What is the value they have asked us? I need to calculate what is the percentage overshoot that is obtained. So I need to calculate MP. What is the formula for MP? E to the power of pi into zeta divided by root of 1 minus zeta square. So I know what is omega n, I know what is the value of zeta. So here I am substituting. Omega n is not required for this formula. So whatever the value of zeta n is there, the value of zeta n is substituted here. Since they are asking us in terms of percentage, I need to multiply that by 100. If they don't ask in terms of percentage, no need to multiply with 100. So 1.92% is what we are getting as the first overshoot value. Now the next problem is, a feedback system is prescribed by the following transfer function. G of s is equal to 12 by s square plus 4s plus 16 and h of s is given as k into s. They have also given us the damping ratio of 0.8 and they have asked us to determine the overshoot for the system when the value and the value of k. Now we know that. What is the formula? The formula is feedback system. So C of s by R of s is equal to what? G of s by 1 plus G of s into H of s. So I substitute the value of G of s by 1 plus G of s into H of s. So G of s value I know here, H of s value I know here. So I substituted that and I brought it into the standard quadratic equation format. So this is our standard quadratic equation format. Now once I get this equation, I have to compare with what? The standard format. So in the standard format, it is s square plus 2 zeta omega n plus omega n square. Now what is in the place of omega n square? What is the term that I am having? I am having the term as 16. So what is omega n square equal to? 16. If omega n square is equal to 16, what is my omega n value? Root of 16. What is this root of 16 equal to? It is equal to 4 radians per second. Next, I have to find out what is the value of zeta. To find out what is the value of zeta, 4 plus 16 into k. So 2 zeta omega n is 4 plus 16 into k. Substitute the value of zeta. Why substitute the value of zeta as 0.8? Because they only have given us the value of zeta to be equivalent to 0.8. So substitute the value of 0.8 here and find out what is the value of k. So what is the value of k here? The value of k is equivalent to 0.15. So at zeta is equal to 0.8, the value of k is said to be equal to 0.15. And how much is MP? Same formula. Substitute the value of zeta here. I can find out what is the value of MP, which is equal to 1.5%. So I think we have done with respect to the first order, second order, and we have also solved some problems. Later, we will solve some more problems of with respect to the second order system only, and lastly, we will solve some problems with respect to the steady state error.